Okay, so this is lesson 7.1, B as in boy, the day after Thanksgiving, 82 degrees in Central California, sitting out at the picnic table doing this lecture, missing Alaska. All right, finding the general term. When only the first few terms of a sequence are known, we can guess what the general term is, what the equation basically looks like in order to get the sequence that they're giving us. So what we're going to do here is we're just going to kind of predict a pattern, if we can, and see if we can get an idea of what this is going to look like. So, for example, this is A. Okay, that pattern goes on and on and on, and so we do something to this 1 to get the square root of 2, something to this to get the square root of 3, something to this to get the 2, etc. Okay? So we're just going to kind of guess on what this is going to be. Okay? So we might say, the general term of this equation might be something like that. Okay, so let's look and see what happens. If I have A1, which is my first right there, and that equals the square root of 1, which is 1. All right, let's look at 2. Okay, again, because our x values, the pattern here is always going to be, starting at 1, go 1, 2, 3, 4, 5, 6. So that's what we're trying to see what happens here. If I want to get to this, what do I have to do to the 2 to get there? Well, if I take the square root of it, I get the square root of 2, which is what I wanted right there. So how do I get the square root of 3 from n being 3? Same thing. And if I have a to the 4th, I get the square root of what? Whatever number this is, which equals 2, which is how I got that. So see what I'm doing. I'm looking for an equation, or a general term is what it's called, like this, so that when I look at whatever value this is and I plug it in here, I'm going to get this number. So if I start with 1, how do I get this 1 to end up being 1? Well, if I just make it 1, it would give me 1. But when I put in a 2, how do I get the square root of 2? Well, I have to square root the 2, and I get. So see how if I make the square root of whatever number this is, I'm going to get these numbers here. And if I keep going, I'm going to get a to the 5th equals square root of 5, which is the square root of 5. So that would be my next number. And I can just keep going on and on and on with this sequence, because I was given enough information, I could kind of design a general term there and do that. All right, so let's look at some of these that are a little bit more tricky in exercise number 2. Let's see, B, -1, 3, okay, so I'm trying to come up with this formula here. All right, so one of the things I do is I realize that I'm going to have how many numbers are there? There's 5 there that they show me, okay? One of the things I know is these alternate back and forth from positive to negative. So because of that, I know that I'm going to have a -1 to the nth power. So let's do A. This is my formula over here that I'm trying to develop. So I know it's going to be -1 to the nth power in order for me to have that alternating sequence there. So that's part of it. So I'm going to have that. And here I'm going to have -1 squared and -1 cubed and -1 to the 4th, -1 to the 5th. Okay, so all I did was I took whatever number was here and put it, here's my exponent, because that's what it says to do. Whatever number is here, we make the exponent. Okay, so now how do I get a negative 1? I've got the negative. So how do I get the negative 1? Well, I can't necessarily find out just from that, so I'm going to have to look at some of the other numbers. All right, and as I look at this, how do I get this to be a 3? Okay, and this is where it gets a little tricky. Actually, for the second one, if I do 3 to the 2 minus 1, that gives me a positive here, and a 3 to the first power, which equals 3. Okay, so that one worked. If I take whatever number is here and put it here, subtract 1, all right, that worked for that one. Let's try the same rule here. I've got a 3. Whatever my n is, I'm going to subtract 1 from it, and this gives me a negative. This gives me a 9, and that's what I have here. So that worked. Okay, this gives me 3, and I'm going to put a 4 minus 1. So this gives me a positive. 4 minus 1 is 3. 3 to the third power is 27, which is what I have there. So my formula then is 3 to the n minus 1. So again, all this does is tells me that I'm alternating signs. This is the formula that I'm going to use in order to get these numbers. So you just kind of have to play around, you know, and like I say, it's not going to be necessarily perfect, but it's going to be a prediction based on the pattern that we have. So that's what you're supposed to come up with. A little bit tricky. Okay, let's look at C. Okay, so for this one, what can we put in order to get a 2? We could write this as 2n, right? Which would be 2 to the first power, which means my first number would be a 2. And if I do this here, that works. And if I do this here, that works. Which means a to the fourth, if we had it, would be 2 to the fourth, which would be 16. Okay? Now at the bottom of page 578 it says, yes, this could be a possible general term right there, but what if we got the second term by adding 2, the next term by adding 4, the next term by adding 6, this whole thing here would be this way, because we really don't know what comes after 8, just given those numbers. This would be 14, and then we add 8, and then we add 10, and then we add 12, and then we add 14. See, so we could get something like this, or we could get 2, 4, 8, 16, 32 by following this formula, or we could get this by following a different formula. Even though we started out with 2, 4, and 8, that doesn't guarantee that this sequence is going to be the correct one. If we use this sequence here, we'd get a of n equals n squared minus n plus 2. This sequence, or this general term, would give us this. This one would give us 2, 4, 8, 16, 32. But since we don't know what follows 8 here or here, we're just kind of guessing when we come up with a general term here for what we've been given. So anyway, just nothing real big there, because this or this is correct. It doesn't really matter which one, as long as it works with the numbers that they gave you. And the more numbers they give you, the more accurate your general term will be. The fewer numbers they give you, the more of a chance that there are several different equations that you could come up with. All right, so let's look at sums and series on page 579. Given an infinite sequence, which means your x value, or your value is going to be a1, a2, a3, a4, a5, all the way to a to the nth power, all the way to infinity. Now, what would happen if we added these numbers up that we get for A1, A2, A3, A4, and we added those up? That's what is called a series. And if we add an infinite number of numbers up, it's called an infinite series. And you're wondering, how in the world do you do that? Well, that's quite a bit later in your math career. A partial sum is the sum of the numbers that they're asking for. Okay, it's also called a finite series or an nth partial sum. And it's denoted, when we're looking for a partial sum, it's denoted by that, s to the subscript n. All right, so let's look at example 3, kind of give you a feel for it. And they give you a sequence. So what they're giving you is your y values. If you put in certain numbers for x, it's going to spit out these y values. So just remember, the sequence is the set of y values given x is 1, 2, 3, 4, 5, whatever. All right, so this goes on to infinity. And we have that. So notice, if we have a 1 and we do something to it, we're going to get a -2. Put in a 2, we're going to get a 4. Put a 3, okay, so it's always a 1. And some people, I see them do this to show what that n value is, or that x value is. They put in an x, and what do they expect the outcome to be? That. Now notice, they switch, they alternate back and forth, and at this point we don't really care. The A part says, what is S1? What happens if I take the value of my first number and add it, well, to nothing? There's nothing to add there because it's just wanting to know the first value. So I get -2. Okay, it's just asking what that first number is. S4 says, what happens if I add up the first 4 answers there? Okay, so what it's saying is, what do I get when I add up my first 4 outcomes, or my 4 y values given n is 1, 2, 3, 4. Okay, so I just add those 4 numbers up. Don't forget your negatives and your positives, and you get a 4. -2 plus 4 is 2. Minus 6 is -4. Plus 8 is +4. If I have s to the 5th, that's saying, what is -2 plus 4 minus 6 plus 8 minus 10? So it's going to be whatever we got here minus 10. So it's going to be a -6. Okay, because this is what we found when we did the 4, and then we just did a -10 there. Okay, so that's the sum of the first 4 terms, the first 5 terms. This one here is the first term. All right, so I'm going to stop this right now, and we've just got 2 more sections, sigma notation and recursive definitions, and then we'll be done with section 7.1.